Hello and welcome to the session on permutation and combination. In this video, we will discuss the fundamental principles of counting. So if you know NPR, NCR or any of the advanced formulas, please try to avoid them. Please just look at the most basic concepts. I don't know why, but permutation and combination as a topic, as a subject, it scares a lot of students. That should not be the case. It is very simple. It is, as a matter of fact, as simple as multiplying and adding things. And that is all that we are going to do in this video. We'll also have a lot of examples in this video just to explain the concepts. So without wasting any time, let us begin. Now, when two tasks are performed in succession, that is one after the other, or they are connected by an AND, then we'll have to multiply the individual number of ways. However, when the two tasks are performed and they are connected by an OR, that either this happens or that happens, then you have to add the number of ways. Now let's say a simple example would be that imagine a shop which has D doors and W windows. If a thief wants to enter via a door or a window, he can break in just whichever way he likes. Then he can do it in D plus W ways. Those are the total number of choices that he has. However, if later you found out that the thief entered via a door and left via a window, how many choices did he have? He had D choices for the door, he had W choices for the window, or you can say that he had a total of D into W choices or D into W ways. Not clear? Let us look at a few more examples. Now let's say, suppose you have 20 shirts and 10 pants. In how many ways can you decide what to wear? You can pick up any shirt that you like and you can pick up any pant that you like. These two decisions are independent of each other and they are happening at the same time. So you will multiply these values and your answer will be 200. Think of it as independent decisions. As an independent decision for a shirt, you had 20 choices. As an independent decision for a pair of pants, you had 10 choices. Your total number of choices was a combination of the two decisions taken simultaneously, and you had to wear and pants. So you have to wear a shirt and a pant. So that is why it will be 20 into 10 or 200. However, in a slightly different case, if you have 20 shoes and 10 slippers, then what would happen? Well, you will either wear a shoe or you will wear a slipper. You cannot wear a shoe and a slipper. So in this case, your answer will be 20 plus 10 or 30. Now let us look at a combination of this case. That is, you have 20 shirts, 10 pants, 20 shoes and 10 slippers. Now what will happen? Well, once again, look at independent decisions. For your shirt, how many choices do you have? 20. Independent of that, how many choices do you have for the pants? 10. Independent of that, how many choices do you have for your footwear? Well, you can either wear any of the 20 shoes, or you can wear any of the 10 slippers. So that is why your answer will be 20 for the shirts into 10 for the pants into 30 for the footwear, or your overall answer will be 20 into 10 into 30, which comes out as how much? I think 6,000 choices is the total number of choices that you will have. Now, let's say that you have 5 friends and you want to invite them to a party. So how many choices do you have? For the first friend, you have 2 choices, either you will invite him or not. For the second friend, you will have again 2 choices. For the third friend, you will again have 2 choices, invite him or not. Fourth friend, again 2 choices, invite him or not. Fifth friend, again 2 choices, whether you will invite him or not. Or your total number of choices will be 2 to the power 5 or 32. Now let us look at a slightly different problem. In how many ways can you send 5 children to 7 classrooms? It is very related to this, but slightly different. The first child has how many choices? The first child can go to any of the 7 classrooms. The second child once again can go to any of the 7 classrooms. The third child can once again go to any of the 7. Fourth child, again any of the 7. Fifth child, again any of the 7. So the total number of choices which are there, or the total number of ways possible, is 7 to the power of 5. A very common confusion is that why am I not looking at the classroom perspective? So let me look at the classroom perspective. In the first classroom, any of the 5 children can come. But let's say 3 children come. Now, for the second classroom, the choice is not independent. Because if 3 children have already gone to classroom 1, classroom 2 has to pick from the remaining 2 children. So as you can see, choices are not independent. But here, if I was looking from the child's perspective, first child's decision to go from classroom 1 to classroom 7 is independent of second child's decision to go from classroom 1 to classroom 7, is independent from the third child's decision to go from classroom 1 to classroom 2 or any of these 7. So these are independent choices happening at the same time. That is why they are multiplied together to get 7 to the power of 5. Now, in how many ways it will happen such that no 2 children are in the same class? So now for the first child, there are 7 choices. He can go to any of the 7 classrooms. For the second child, there are not 7 choices. Why? Because one particular classroom has already been occupied. So the second child has 6 choices, third child has 5 choices, fourth child has 4 choices, and the fifth and the final child is left with only 3 choices to pick from, or it would be 7 into 6 into 5 into 4 into 3. So how about if the question was such that there are at least 2 children in the same class? That is question 7. Well, that will simply be 7 to the power 5, which was the total number of ways. From that, if you remove the number of ways in which none of them are in the same class, that will give you your desired answer. You can calculate it, but it is important to understand the idea. No restriction, it was 7 to the power 5. No 2 children in the same class was 7 into 6 into 5 into 4 into 3. Such that at least 2 children are in the same class. From the total, remove the unfavorable ways 7 into 6 into 5 into 4 into 3. That will give you your required answer. Let us move on and try a few more problems. Now, how many 3-digit numbers are there? This is an easy one to solve. Why? Because the first digit can be filled in 9 ways. The second digit can be filled in 10 ways. Any of the 10 digits can come. On the first place, 0 could not come. And the third digit can also be filled in any of the 10 ways. So there are a total of 900 3-digit numbers. Now, how many are there such that the digit 6 does not appear? Well, if the digit 6 does not appear, for the first position, how many choices do you have? Now you have 8 choices. Why? Because 0 cannot come and 6 cannot come. For the second position, how many choices do you have? You have 9 choices. For the third position, how many choices do you have? You also again have 9 choices because only 6 cannot come. So first position 0 and 6 cannot come. Second position 6 cannot come. Third position 6 cannot come, which is actually 8 into 81 or 648 is the answer to this one. How about such that the digit 0 does not appear? Will it be any different from such that the digit 6 does not appear? Yes. Because if the digit 0 does not appear, how many choices do you have for the first position? It is 9 choices because 0 anyways was not coming there. For the second one, again 9 choices because 0 cannot come here. For the third position or the third digit, again 9 choices. And in this case, as you can see, the answer is not 648 but 729. Once again, because 0 could not come on any of these positions. Now, a slightly more difficult question which is asking how many 3-digit even numbers can be formed from 0, 1, 2, 3, 4, 5. Before even solving this question, you need to understand one basic idea. 0 is a special case. Why is 0 a special case? Because 0 cannot come at the first position. So we need to take care of that fact. How do we do that? We will consider 2 cases. Case 1, when 0 comes at the last position, and case 2, when 0 does not come at the last position. And then either of these cases will happen and we will add them to get the result. So when 0 comes at the last position, how many choices do you have for the first digit? For the first digit, you have anything from 1, 2, 3, 4, 5. For the second digit, you have anything again from 1, 2, 3, 4, 5 can come. Even a 0 can come. So you have 6 choices, and for the last position you have just one choice because 0 is coming there. So you have a total of 30 choices when the digit 0 comes at the last position. How about when 0 does not come at the last position? Well, for the first position, how many choices do you have? You can have anything from 1, 2, 3, 4, 5. So you have 5 choices for the first position. For the second position, how many choices do you have? Any of the 6 numbers can come. So again 6 choices. For the last position, how many choices do you have? Anything other than 0 can come, or you have a 2 and a 4, or you have 2 choices for the last position, which is 60. So your total number of ways is actually 30 plus 60, which is equal to 90 is your answer. But if you understood this, can you try and calculate the same question with the restriction that there is no repetition? Will the answer change? Yes, the answer will change. Why? When 0 comes at the last position, the first position will have 5 choices. Any of 1, 2, 3, 4, 5 can come. For the second position, how many choices will you have? 0 has been used at the last position, 1 digit has been used at this position, and you are left with 4 choices. So when 0 comes at the last position, in the no repetition case, you will have 20 ways. When 0 does not come at the last position, well, how many choices do you have for the last position? You have 2 choices. It will either be 2 or it will be 4. How many choices do you have for the first position? 1 digit has been used here. 0 is not allowed here. So for the first position, you have 4 choices. For the second position, how many choices do you have? 2 digits have been used. One at the first position and 1 at the last position. Any of the remaining 4 digits can be used here. So this will be 4. So you get 4 into 4, 16 or 32. And your overall answer comes out as 20 plus 32 or 52 in this particular case. So please remember, whether it is a repetition or not a repetition, that makes a lot of difference. Let us look at a few more problems now. In how many ways can 8 children sit on 8 seats numbered A, B, C, D, E, F, G, H? Well, for the first seat, you have 8 choices, or for the first child, you have 8 choices. For the second child, you have 7 choices. For the third child, 6. Fourth child, 5. Next child, 4. Next child, 3. Next child, 2. And for the final child, you will have just 1 choice. Or this can happen in 8 factorial ways. Now, how many ways are there that Ramesh is fixed on seat C? So if Ramesh is fixed on seat C, then what will happen? Another thing which I like to highlight here is, so this is n children on n seats, or n things on n positions can essentially be n things on n positions can essentially be arranged in n factorial ways. Now keeping that in mind, Ramesh is fixed on seat C, 7 children are left, 7 positions are left, can be arranged in 7 factorial ways. Now, how about Ramesh is on seat B and Suresh is on seat C? 2 people, 2 seats are fixed, 6 people are left, 6 children are left, and 6 seats are left, can be arranged in 6 factorial ways. How about this one? Ramesh is just to the left of Suresh. So Ramesh and Suresh can be tied together with a string, considered as one entity. That one particular entity and 6 other entities. Ramesh and Suresh, one entity, 6 other entities. So they can be arranged in how many ways? They can be arranged in 7 factorial ways, because that is 1 plus 6 factorial. Now, how about Ramesh and Suresh are together? Very similar to the previous case. Tie them with a string, get 7 factorial as the answer. But is that the final answer? No. Your final answer will be 7 factorial into 2. Why? Because 7 factorial is when Ramesh is just to the left of Suresh. There will be another case when Suresh is just to the left of Ramesh. Or essentially what I am trying to say is that Ramesh and Suresh can arrange among themselves in 2 ways or 2 factorial ways. How about this one? Ramesh is to the left of Suresh. I don't know, just left or much before left or whatever. Well, this will be half of 8 factorial. Why? You consider the total number of ways, that is 8 factorial. In half of them, Ramesh will be at the left of Suresh. In half of them, Suresh will be at the left of Ramesh. So we like half of the cases, and that is why our answer is half of 8 factorial. Now, let us look at a few more, such that Ramesh and Suresh are at the corners. So if Ramesh and Suresh are at the corners, they can be arranged at the two corners in 2 factorial ways. The other 6 people, the other 6 children can be arranged in 6 factorial ways. How about when Ramesh, Suresh and Dinesh are together? Then Ramesh, Suresh and Dinesh can be considered as one entity. How many other entities are there? 5 children are there, so 5 more entities are there. So they can be arranged in 1 plus 5 or 6 factorial ways. But is this the final answer? No, because Ramesh, Suresh and Dinesh among themselves can be arranged in 3 factorial ways. So your actual final answer will be 3 factorial into 6 factorial. Now, for the final question of this video, Ramesh is to the left of Suresh and Suresh is to the left of Dinesh. This is possible in 8 factorial by 6 ways. Or rather, let me put it this way, 8 factorial by 3 factorial ways. Why so? Because Ramesh, Suresh and Dinesh among themselves can be arranged in 3 factorial ways. Out of these 3 factorial ways, we like only one of them. Total ways are 8 factorial. And so, out of 8 factorial, we like 8 factorial by 3 factorial ways. What I am trying to say here is that out of every 6 ways, we like one of them, and that is why we do 8 factorial by 6 ways or 8 factorial by 3 factorial ways. With this, I'd like to wrap up this session. Please provide feedback via Twitter at my Twitter handle @RaviHanda. You can also email me on my mail ID, which is ravihanda@gmail.com. Thank you.